In this video, we are going to work this problem. We are going to classify the critical numbers of f as local max, local min, or neither. Okay. So if you haven't watched the previous video, then you need to go back and watch that. In that video, we answered the problem about where, on what intervals is this function increasing and on what intervals is this function decreasing. In the process of answering that question, we came up with this sign diagram, right, for f prime, the derivative of f. And so this is really all we need to answer this question. In the process of developing this sign diagram, right, we had three possible critical numbers: 0, 1/3, and 1/2, right? And remember, the possible critical numbers have to be in the domain of the function f in order to be actual critical numbers. So 0 and 1/2 were in the domain of f, right? So we classified those as critical numbers. But 1/3 is not a critical number, right? It is not in the domain of f, okay? So, so on this one, we don't even have to worry about 1/3. We're not going to classify that as anything because it's not even a critical number. Okay, so let's start with our first critical number. Our first critical number is 0, right? So we can look, and to the left of 0, here, the interval that's immediately to the left of it, we can see that the derivative was negative. So what that means is that the original function will be, oops, I'm having some issues here. Let's see. There we go. That means that the original function f will be decreasing, going down. And then to the right of 0, the original function is decreasing again. Okay? And so looking at that, we can see that 0, right, is neither. So it is neither a local max nor a local min, right? Because it doesn't matter how close you get to that point on the graph corresponding to 0, there's always going to be some points that are a little bit higher and some points that are a little bit lower. So it can't be locally the highest or lowest, okay? All right, 1/3, again, we don't even worry about that. It's not a critical number, so we move on to 1/2, right? All right, and so looking at 1/2, we see that immediately to the left of 1/2 on the interval immediately to the left, the derivative was negative. That means the original function f had to be decreasing. Then on the interval immediately to the right of 1/2, we see that the derivative is positive, right? So that means that the function was then increasing to the right of 1/2. So you can see that we'll have a local low point, a local min, right, at that value of 1/2, okay? If I look and zoom in on the graph close enough, right, and only look at that little piece, that point will be the lowest point on the graph, okay, that we can see if we zoom in enough, all right? And that's it on this one. Again, if on the quizzes, I'm just asking, in my class, I'm just asking in this manner, classify the critical numbers as local max, local min, or neither. If you're in another class or working through some problems in a book, they might ask for the local max values or the local min values. When they use that word value in connection with local max or local min, they are asking for the y values of those points, and these are the x values. So if they're asking for the values, what they'll do is you'll need to take these numbers that just this one, right, and plug it back into the original equation to get the y value of the point on the graph corresponding to 1/2. Okay. All right, that's it.